Let's answer this question on right triangle similarity. This is provided to us by one of our supporters. So here's how it is done.
Math in question. Think. Inquire. This is MATHinQ. Answered questions. This is an example of a right triangle similarity problem. We are tasked to solve for the given unknown using the given measurements here. Now, the important thing whenever you have to answer a problem which involves right triangle similarity theorem is to break it into different triangles. It is stated that in a right triangle, in this case, triangle A, M, and G, the large triangle, if a segment or the perpendicular line from the vertex of the 90-degree angle towards the opposite side or the hypotenuse of triangle AMG, as long as it is perpendicular to that side, we have established here not just two, but three different triangles that are similar to one another. That would mean we have the large triangle here, we have this medium-sized triangle, and we have here the smaller or the smallest triangle. All of them are similar to one another. Using that concept, we could come up with proportions in order for us to solve for the given unknown. So let's try breaking this into three triangles. And this is my suggestion whenever you are to answer right triangle similarity problems. Of course, there are also another strategy in solving this, but I'm just going to present here the longer method so that you could also implement this as you will have your similar problems. So first, let us break it. Let's have the largest or the original given triangle. I'm placing it in this manner, considering the rotations and necessary translations, so that we could easily look into the correct sides that are part of our proportion. Of course, this is where our 90-degree angle here, that would mean this is M. And looking into our original triangle, we have the shorter side and the longer side. The shorter side is with X. In short, this is A here, and this is where our G is located. Aside from X, you can also plot here the value of your hypotenuse, 36, but of course, plus 64, as this is the entire AG segment. In short, the hypotenuse is 100. Just by looking into this, we cannot solve this yet if we are going to use other concepts like the special right triangles, the 36 and 90, or the 45, 45, 90, because we don't do the measurement of any of the angles except for the 90 degree. At the same time, we cannot use here the trigonometric ratios because we also need the measurement of one angle or measurement of one angle in order for us to solve for this item. So let's continue plotting here the next triangle. We have the medium-sized triangle here. Now, this is very important to be reminded of, that you need to really look at your given as you will try to consider translations, rotations, etc. Of course, it is perpendicular. We also have here 90-degree angle. Hence, it is E here. Looking into that, the original perpendicular line drawn, I'm talking about this line here, or let me use other color, this line here, is actually this shorter side of our given. This would mean this is our M here, and the remaining vertex is G. Now, you can plot here, of course, 64, as this is our EG. We don't know this. We don't know the measurement of this as well. So let's leave them in the meantime. And of course, the last triangle, we have the smallest triangle of all. I'm just trying to approximate the figure. Okay, so looking into that, you would see that this is actually AE is our shortest side, with E as our 90-degree angle here. That would mean this is A, having 36 here, and this is our M with X on this side. Now, we have established the three different triangles that are considered to be similar, because that is what the right triangle similarity theorem tells us. In order for us to solve our unknown, let's look at the triangles here where the unknown is present. The unknown is present at triangle 1, the large or the original triangle, and X is also found on the smallest triangle with X here. Let's try to come up with our proportions in order for us to solve this given item. Before we continue, we would like to emphasize that you can join us on our social media platforms. On our YouTube channel, please subscribe. You can also follow us on our TikTok account. And of course, for more information, follow us on our Facebook page. Once we have established that triangles are similar, we can now take the ratio of the corresponding sides and come up with a proportion. I'm talking about this. Let's consider this side of the large triangle. That is side AM or MA. It depends on how you will name that one, as long as you will also consider the right naming on its similar triangle. We can use our middle-sized triangle, but since it doesn't have the unknown, so let's skip that. AM here, when paired to its corresponding side, I'm talking about AE. So AE. The ratio of this, or you could also interchange them, smaller to larger, it's okay which you will use, as long as once you use the side of the largest triangle here, you will also use that to the rest of the ratio. To come up with the proportion, what we need to do here is this. Since AM is a side of the largest triangle, let's continue drawing. You will have here our MG, the longer side or longer leg, and this is actually paired to EM here. And finally, you will have your AG, the hypotenuse of the largest triangle, and the hypotenuse of our smallest triangle. This is the proportion concerning the similarity between the triangle 1, the largest triangle, and the smallest triangle, which is a portion once you again draw this line here, perpendicular line from the vertex of the large triangle to its opposite side. Now, this proportion will be used to solve for the items. Let's plug in the values if they are present. AM is X over AE is 36. MG is unknown, as well as EM. So let's have here unknown. You can use other value for that. And you will have your AG is again the total is 100 over your AM, which is X. In short, we will be using these two ratios for our final solution, which means since they are equal, X over 36 is equal to 100 over X. Simply try to use the fundamental law of proportion, or multiplying extremes and means, or in other sense, cross multiplication. You will have X squared is equal to 3,600. Then you can simply take the square root of both sides. You will have the square root plus minus square root of 3,600. Then further, you will have here the result of plus minus square root of, actually take note, this is 36 times 100, and they are both perfect squares. So X is plus minus, your 36 is actually 6 times 10, or 60. X is plus minus 60. This is the measurement of the unknown. But which of the two? We have two values. X sub 1 is 60 units and X sub 2 is negative 60 units. It's also important for you to determine which is the final answer, because both positive and negative 60 are not acceptable. Because when we talk about X being the measurement, we will consider the positive value because it's a measurement, it's a distance between points. We are going to consider 60 units, and we don't have negative negative measurements, so this is not possible. So this is now the answer to the raised question. If you still have more questions regarding to this or other math concerns, please do not hesitate to contact us or drop it on the comment section below. Math in question. Think, inquire. This is MATHinQ. Answered questions. Subscribe now.